We're looking at intervals today. These are going to be some kind of range of values from one endpoint to another, literally an interval, okay? And we're going to see how to represent this in three different ways. So let's look at the first way. That's going to be using what we call interval notation, okay? Interval notation looks something like this. You're going to probably start it with a bracket or parentheses, and this will be the interval from 1 to 4, okay? So representing all of the values from 1 to 4, and we call this a closed interval because we're using brackets here. So that means this interval from 1 to 4 is going to include the values 1 and 4, all right? So this is interval notation. An ordered pair of numbers, it's very simple. We can also represent an interval using a real number line. So we can represent it graphically. Okay, so let's do that. Let's represent this on a real number line. So let me draw a real number line here. And let's say this is the origin. Here's the number 1, 2, 3, 4, and 5. Okay, so what I'm going to do now is I'm going to draw a dot, draw a point here at point 1 and also at point 4. And I'm going to fill these in. So these are filled in dots representing a closed interval. And then I'm going to draw a line here. Okay, so let me make that a little bit bigger. This line is just filling in the entire interval between the endpoints. Okay, so this represents a closed interval, and it's going to be including the values 1 and 4. So here's an interval from 2 to 5, and now I'm using a parentheses here. So this is going to represent some kind of open interval. An open interval does not include the endpoints. So it'll be all of the numbers between 2 to 5, but not including 2 or 5. Okay, so this is an open interval. And once again, let's represent this graphically using a number line. So here's 0, 1, 2, 3, 4, and 5. And so what I'm going to do now is I'm going to draw my endpoints. And it starts at 2, but I'm going to use an open circle, not a filled in circle, because this is an open interval. Same thing here, because I'm not including the actual value of 2 or 5. So it's an open interval. And then I'll fill in all of the interval here between them, right? So let me make that a little bit bigger. So there we go. This is now going to be our open interval from 2 to 5, and it is not including 2 or 5. So this is interval notation, and we can see it represented graphically as a real number line segment, but we can also represent intervals using set notation. So let's take a look at that. So let's use this to define now the interval from A to B. Okay, this is going to be an open interval. And essentially, we need to define the set of all real numbers between A and B, not including A and B. Okay, so we're using set builder notation. First, we're going to define our domain. So it's going to be all x, that is the element of the set of real numbers, such that A is less than X is less than B. And there we go. That is our set that defines this interval. Okay, so it's the domain here. We're using real numbers. So we're going to have all the real numbers between A and B, but not including A and B, right? This is not a less than or equals to sign. This is just a less than sign. So there you go. That is going to be exactly this interval. Now, if we assume that this is always, we're always talking about the domain of real numbers, maybe you state that ahead of time and say we're dealing with only real numbers. So let's do that. We're going to assume the domain is dealing only with real numbers. Let me show you how we can represent a few other types of intervals. Okay, so here's the first one. Here we're going to have an interval from A to B. But notice we're mixing this up. This is like a half open or a half closed interval. So we're open on A but closed on B. Okay, so how would we represent this using set builder notation? So set builder notation, I'm just going to write all x. We're assuming the domain is real numbers, so I'm not going to bother writing it's an element of the set of real numbers. So it's all x such that a is less than x is less than or equal to b. And there we go. That is going to be my set for this interval. Okay, so this side is closed, this side is open. And of course, I can represent this also as a graphical element here on the real number line. Okay, so what would that look like? Well, essentially what we could do is we could define 2 points, and it's going to be open on A and closed on B. And so what we're going to get is this interval right there. Okay, so you can replace A and B with any specific number that you want to deal with, but this is how we would represent this interval, both using using interval notation, using set builder notation, and graphically using a real number line. Let me try and show you 2 more examples here. Let me show you this interval here where we're going to start at A and then we want to keep on going forever. Okay, so this interval we'll say will go to infinity. And what I want you to notice is that when we're using infinity here, we always represent this with an open interval. Okay, so that's because infinity it's not a real number. It's not possible to ever get to infinity. Instead, this symbol represents the idea that you keep going to the right forever. You could also use negative infinity, maybe on this side, to represent going to the left on the real number line forever. Okay, so it's an important idea here that when we use infinity or negative infinity, we're always going to be representing this as an open interval. Okay, so that's the idea here. Okay, so how would we now represent this interval using set builder notation? So again, all x, we're assuming real numbers. There it's going to then go from a less than or equal to x less than infinity. Okay, so that is set builder notation, and we should be able to represent this graphically on the real number line. And so here, what are we going to have? Well, we're going to have a closed here on A, and then it's going to go on forever. Okay, so what we do is we just fill in the entire real number line just like that, going on forever. Let's do one more. This interval is going to go from negative infinity to positive infinity. So what does that represent? Well, if you think about it, that is literally all of the real numbers. And so we don't even have to bother using set builder notation. We can just say that this is the set of all real numbers. There you go. And how would you represent this then on a real number line? Well, you would just have to color in the entire real number line. Just like that. Okay, so there are 3 ways that we learned here how to represent an interval. We looked at interval notation using either brackets or parentheses, right, to represent open or closed boundaries. We looked at set builder notation, and we looked at the real number line and how you can draw essentially line segments on the real number line using either closed or filled in points to represent closed or open interval boundaries.